This function question is the Leaving Cert Paper 1 Question 7, 2024. Who is it suitable for? Leaving Cert, ordinary level, junior cert, higher level. There is a portion in this question that will not suit junior cert, higher level, or will not suit a Leaving Cert ordinary level who has not done calculus yet. That does not mean that you don't watch the rest of the video. It is this portion in here. I will tell you that, and you can just skip forward until the last piece. Okay, everyone? So, off we go. Junior cert, higher level, and Leaving Cert, ordinary level. During an experiment, the number of bacteria in a dish can be modelled by this function. So, t cubed minus 6t squared plus 6t plus 20. It's sort of like a formula that's going to tell me after 1 hour how much bacteria is going to be in the dish, after 3 hours, and so on. You fill in the amount of time that you want to get the result out. If you're using a Casio, I don't like the new Casio, so I'm still on the old. You're hitting menu and 3 and typing that function in. You cannot type t into your calculator. You're going to have to type x instead of t. So it's x cubed is what you're putting in. Alpha, close bracket to get your x up. Then your little box with a cubed. The over button. Minus 6 alpha, close bracket again with a squared. Plus 6 alpha, close bracket again, plus 20. So it should look like this, if you can see it as best you can there. Very, very hard to see the calculator on the video, guys. Then you want to hit equals. We're skipping over the g of x with another equals. We're starting at 0. We're ending at 5, and the step is 1. And you've got all your answers there. If you are on the sharp, you have to just type it in individually. So what I've done here is I've just pre-wrote this out, and you need to fill in 0, you need to fill in 1, 3, 4, and write out your answers. So I didn't put in the 0 because it's always the last number, which is 20. Here, you're going to, instead of t, fill in the number 1. So bracket 1, close bracket to the power of 3. Minus 6, bracket 1, close bracket squared. Plus 6, open bracket 1, close bracket, plus 20. And that will give you 21 as a result. They've done 2 for you. Then you have to go off and do 3 and 5. You can retype it out if you wish, or you can just go back and fill in your 3s. And you'll get 11 in here. And then if you go and do the next one on your 5, you'll end up getting 12. So you, unfortunately, on the sharp kids, have to fill it in. It's not that hard. 1, anywhere you see a T, and so on. Right, next up, we have got to plot it. So the time is your X, this guy down here. The number of bacteria is your Y. So along here, I've got 0, and I go to 20 along here and plot. Then 1 and 21, 2 and 16, 3 and 11, 4 and 12, 5 and 12. It's 5 and 25. I apologize. I just wrote it down incorrectly off that there. Apologies. 5 and 25. So 5 and 25 is up here. Make sure you freehand this. And you're all together. So sorry about that, I just looked at the wrong one on the Casio. Junior certs and leaving cert ordinary level who have not done calculus, please tune out until we finish this page here. So the next thing they want you to do is find P, the differentiated version of T. That is the derivative of P of T. So i.e., they want you to differentiate. Let's go. Remember, there's really a secret 1 in there. So you've got 1t cubed minus 6t squared plus 6t plus 20. So that's 3 times 1 is 3t, reduce that power by 1, minus 2 by 6 is 12t, plus, remember this here, 6t, there's really a 1, 1 times 6 is 6, the t reduces down, the number disappears. So that is us differentiated. Next thing, find the value of P, the differentiated version, with a 2 inside. Well, this here is my formula for P, the differentiated version of X. So I'm writing down my formula. And they would like me to fill the number 2 in. So I'm going to put 2 everywhere I see my T and pop them into my calculator, and we should get minus 6. Right. Please explain what this means in terms of the number of bacteria. When you differentiate something, like we did here, it means that you're changing the formula. And if you are changing the formula up, the sum is changing. So it means that 4 are the amount of hours. After 4 hours, the number of bacteria it's changing, but what's happening, the bacteria? It's going to grow, okay? It's going to start growing, because you can see here, it's starting to grow. After 4 hours, the number of bacteria is growing at a rate of 6,000 per hour. So 6 was the result, and they were in thousands. They tell you that back there at the start. That's a tricky enough little question there, and they were quite strict on the marking of it. They wanted the growing at a rate of 6,000. But look, it's only it was changed to 5. It says 10 on the marking scheme, but it was changed to 5 in the end. Okay, all the junior cert and leaving cert ordinary level students who have not done calculus, back to the question. Junior certs, you do not do calculus at junior cert, so that last part was irrelevant. If you're in your leaving cert ordinary level and you haven't done it yet and you've just done functions, that last part was irrelevant. Sort of like a new question here. The number of bacteria in a different experiment can be modelled by this function. K of t equals 3000 by 2.7 to the power of 0.5 t, where k is the number of bacteria and t is the time spent in hours since the start of the experiment from 0 to 8. There are 3,000 bacteria at the beginning. That's where this is coming out of. Use k at t to find the number of bacteria after 1 hour. So you're going to fill 1 in for T. After 2 hours, you're going to fill 2 in for T. And we'll figure out the bacteria. So 3000, this is my formula up here up the top. And I'm going to fill in 1 first. Into your calculator and see what you get. Over here, I'm going to do 3000 by 2.72. And I'm going to fill in 2. And off we go. So when you fill that in, you need to round it to the nearest whole number. You'll get 4947.7267. To the nearest whole number means you look at the number after the decimal, giving me 4948, because this guy is 5 or above, which pushes that 7 up to an 8. Then over here, when we fill him in, we get 8160. Rightio, on to the last part. After n hours, there are at least 35,000 bacteria according to K of T, where n is a natural number. Natural numbers, this thing here, means a whole positive number. Your answer 1, 2, 3, or anything like that, a whole positive number. By continuing the pattern above or otherwise, find the smallest possible value of n. Well, we know 2, so if you went off and you put in 3, what would you get? 4, what would you get? 5, you want at least 35,000. There is an algebra alternative to this, but we'll keep going with this guy for now. Right, if you put these into your calculator, kids, right, the 4, just because I had him done already, will get me 22195.2. The 5 will get me, let me see, $36,605.26. So I didn't do the 3 there really to save time, but I can grab that answer for you. 13,457.82. So we need at least 35,000. This does not match at least 35,000. Does this one match it? No. Here we hit at least 35,000. We got 36,605. And to make your answer absolutely perfect, they wanted the smallest possible value of n as a natural number. Therefore, n is 5. 5 is your natural number there, because it was the 5th hour that we subbed in. That gave us at least 35,000 in bacteria. So I hope that question helps, and we'll see you at the next question.